Today I'm going to show you exactly how I'm evolving my RC car to beat my Guinness World Record of 234.7 miles per hour and chase a slightly ridiculous goal, 250. In episodes 2 and 3 I showed you how I designed, built and tested the Shredder, my tyre testing machine. But you might remember, I said I was going to build a new car. Well, now it's time. The Shredder is going back in its box. Because I need to design a car capable of 250 miles per hour and build it in time for the next speedrun season, which starts in 8 weeks. I've got ideas. Make it narrower, fit bigger motors and run more voltage. Now I need to turn those ideas into a real design. This video is brought to you by Onshape. More on them later. The plan is simple. Follow the same layout as the Beast, because where it works, I'm not changing it. But with 3 key upgrades. Reduce the width as much as possible for aerodynamics. Package larger 5215 motors for more torque and less heat. And add an extra 2S battery, taking it up to the 20S 84 volt voltage limit of the MakerBase 84100 ESCs that I'm using. Simple? Not even close. Because each one of these creates new problems. How narrow can the steering actually go? And what happens to the centre of gravity when I shrink everything? Let's start with the most crucial one, the wheel mountings, because every millimetre adds drag, and it gets doubled because there's 2 wheels across the car. How do I mount a wheel to this and keep it as narrow as possible? Do I use the adapter that comes with it, which is that? Or do I come up with some other way of doing it? This was a real head scratcher. The obvious solution, using the standard adapter, was not good for width. Compared to the Beast setup, I'd be adding 9.9mm per side. I was supposed to be making the car narrower, not wider. After a lot of staring at the CAD screen, I came up with option 2, modifying the adapter to add a hexagon for the wheel. But this would be difficult or impossible, and still 5.1mm of width was added per side. Then I had a flashback to seeing M2C wheel mountings where the wheel gets modified to add new holes. This isn't ideal, but I said I was going to leave no stone unturned in my pursuit of speed, so if I have to modify the wheels, so be it. This allowed me to come up with a design which is actually the minimum width possible, where the wheel hex sits directly on the motor face. I got rid of the 6mm adapter shaft completely and just mounted the wheel with 4 M3 screws, with a small adapter piece and a washer. This solution is only 2mm wider than the Beast arrangement, so they're basically interchangeable, which could be useful in future. And what I've got now is just this tiny little thin thing. So what you do with that, you put it into the wheel, then drill it through from this side, so it drills 2 full holes and 2 half holes in the edge of the adapter area there, and then you can that just goes straight on there with that little plate to hold it on, and the 4 bolts just go straight into the motor. I tried it on my tyre test rig up to 230 miles per hour, and even with only 3D printed parts it worked great. The width across the Beast front end was 233mm. I decided I wanted to take at least 50mm off this width, but like we just saw, things weren't going the right way with version 1 of my wheel adapters, plus 20mm width. So I started by trying to reduce the width in between as much as physically possible. This early layout obviously wasn't finished, but this is what the 70mm width reduction would look like that I'd need to hit my target. The suspension spring would be too narrow, the steering links wouldn't fit and the clearance wouldn't be enough for steering movement. Luckily I came up with the narrower wheel mounting idea, so together with a 50mm width reduction between the steering links I could still hit my target. But there was still a limiting factor. There's a minimum length you can achieve with these M4 turnbuckles of 65mm, so I set my width based on that. I turned the servo 90 degrees to fit it in, and I still needed some kind of special link to attach the servo to the steering arm, which is only 33mm long.
My first idea was a CNC aluminium link with spherical ball joints, but I couldn't even find suitable joints to buy. Then I realised I could just cut down 2 M4 rod ends and join them together with threaded rod. Simple. Overall width 185mm, only 2mm over the -50mm target I set at the start. I could have gone narrower by modifying the turnbuckle link, but steering clearance was already getting tight and the chassis and spring would get narrowed and weaker, so I decided to stick rather than twist. By comparison, the rear end was easy. With no steering to fit in, I could just bring it into the same width as the front, actually 56mm narrower than the Beast rear end in total, since the Beast was wider on the back end. So an average of 52mm width reduction. That's about 20% of the total body width, which is going to be massive when it comes to minimising drag. This is the point about which the car's weight acts. On the Beast car, I had this point 55% of the wheelbase from the rear wheels, which means that 55% of its weight was on the front wheels. That's important in helping the car not to flip up. But for Project 250, I found a problem. Let me explain. With the narrower chassis, the speed controls didn't fit in anymore like they did on the Beast, so I had to turn them round by 90 degrees. This pushes the batteries rearwards, which, when you compare it to the Beast's layout, makes it not very surprising that there's now only 48% of the weight on the front wheels, which is not what I want. So I explored different layouts. Putting the speed controllers vertically, that gave 50.6% weight on the front, so a little bit in the right direction, but still a long way from where I needed to get. Then I got radical, hanging the speed controls out of the front of the car, and that gave 53.8% of the weight on the front, so almost there. Finally, I added a 2-cell LiPo in the gap, giving me the 20-cell setup that I wanted to go for, and exactly 55% of the weight on the front of the car, and I took that as a sign that this was just meant to be. Another option would have been to extend the wheelbase, but I didn't want to do that as this thing's pretty long already. So this became the direction. To check everything fits, I needed a body. The goal was always evolution, not revolution, so it looks like the Beast, but narrower. Because the front needs space for steering, the body naturally tapers towards the rear, which could actually be more aerodynamic. And even the chassis edges follow this taper. I'll develop this shape with CFD later on. You've probably noticed by now that I've been using Onshape for the Beast and Project 250 so far. It's a professional CAD system, but the big difference is that it's completely cloud-based. That means I can run it on pretty much anything. My main PC, a laptop, even my phone. And I could not have done these projects without it. A few highlights from this video. Onshape keeps a full history of every change you've ever made, so you can literally go back in time, step through your design process and see exactly how things evolved, which has been really useful while making this video. When I was working on the fin design for the body, I initially started calculating an airfoil manually, and then realised Onshape has a plugin that generates it instantly. There's loads of these custom features available and they can save a huge amount of time. I also used the built-in FEA tool in Onshape Professional to refine parts of the design, particularly the suspension. It's really intuitive to use, and I was even able to model the behaviour of the rubber springs, which help guide the final design decisions. Another thing worth mentioning is the support. This week I ran into a couple of small export issues, raised 2 tickets and got really helpful replies within minutes. So massive thanks to the Onshape team for that. And the best part is, you can actually get 6 months of Onshape Professional for free, so you can try all this out for yourself. Just click on the link at the top of the description. Right, back to Project 250. Now the overall concept had come together, I had a lot of tidying up to do to make the design production ready. And here's what I ended up with. It looked so beautiful, I decided to make it there and then with my 3D printers.
An exciting moment in Project 250 is about to happen. I've got this mock-up chassis. It's a 3D printed version of what eventually is going to be made in carbon fibre. And I've got all the other parts I need here to pretty much build it up into a car, with the idea of checking that all these parts fit properly before I go and get them ordered in aluminium and carbon. Here's the servo I'm using. Thanks, Raz. It looks awesome. So you get, not only do you get this amazing looking servo, but you also get a really nice metal servo horn as well, which looks perfect. That's the name, I guess, Perfect Pass. Haha. So the way the servo goes in, because if I'd made this all one piece, not only would the one piece be very expensive, but you wouldn't actually be able to get the servo in. You'd think I was sponsored by Works, wouldn't you? But I'm not. Maybe sometime in future. Who knows? There we go. Lots of chassis flex, but you know, it is 3D printed. I've maybe got slightly ahead of myself and started putting wheels on this thing.
So I'd finished the 3D printed prototype. Was it useful? Well, actually, I noticed a few things that needed fixing. The first was a major issue: the front mounted speed controller power wires going straight into the wheel. But with the case off, I could see potential for rerouting upwards next to the capacitors. I tried it, filing new holes in the case, and it worked. Thankfully, a simple fix. The second was a case of bendy suspension, as in bending in not the way it was meant to. The steering assembly was rotating forwards. I couldn't tell if this was thanks to the 3D printed parts or the geometry, so I played it safe and made it more like the Beast design, checking it with FEA just to make sure. And in the same area, it looked like I could make an improvement to the servo mounting, making it in all one piece, thanks to an idea from an aftermarket servo mount.
That little recess there allows the servo wire to fit right up high, so then it can easily pivot around and slide through what's left of the gap. So I went back, redesigned the bulkhead so that it's got a one-piece servo mount like that, and crucially it's got that little recess there to allow the servo wire outlet to fit up nice and high and allow the servo to pivot round and slot into position.
I reprinted and checked again. With the suspension looking much better, I could carry on. The final task was checking the battery fitment.
So I've got this all set up with my nice perfect pass battery straps all threaded through. I've only got one side installed at the moment, but I can now strap these in at least temporarily to mock things up. So I'm going to do that and then work out what I'm going to do with the wires to make them fit in. Yeah, so I'm going to have to somehow join these together in series and fit them within the body, which is going to be like right there. So let's just try going black, well, negative to positive. I was going to say black to red, but I mean negative to positive. So that would mean going like this as we go along the chassis. And the trouble with this is it doesn't really squash in very. I don't know, I suppose it kind of squashes in like that, just about. Maybe if that one was inside there, it might work. Yeah, that could be an option actually. So I've got it set up now like I said I was going to, with the balance leads tucked in here. That looks even more neat now, so that these will just tuck inside the frame rail, or the chassis rail, sorry, keeping them inside, so I won't even need any strapping to hold them in place.
But then the rod ends turned up in the post, so I made my special 33mm link, made from 2 rod ends cut and shut together, and got it fitted, and now we have steering. My 3D printed prototype was fully updated and even more complete. This was such a useful thing to do.
So the chassis design is done, and honestly it looks fast. The build reminded me how easy these cars go together. With no drive shafts or gears, it's so simple. Maybe because I haven't done the wiring yet. I can now get the parts ordered, which is critical because the speedrun season starts in just 8 weeks. The body is still a work in progress. I want to refine that properly using CFD before committing. And alongside that, I need to get back onto tyre testing. So there's still a lot to do. But Project 250 is starting to take shape. Remember to check out the link for 6 months free of Onshape Professional. And if you want to follow the journey to 250 miles per hour, make sure you're subscribed, and I'll see you in the next one.